Hello, everyone, and welcome to this session on building resilient on-premises infrastructure tailored for AI workloads using OpenShift. I am Shajeer Mohammed, and today we'll explore how combining OpenShift with Hyperconverged infrastructure, or HCI, can provide a robust foundation for your AI platforms. We will cover key design principles, fault tolerance, automation, and some real-world use cases. So let's dive in. So, platform engineering teams are increasingly responsible for managing the entire stack from the hardware up through software to deliver reliable AI services. This end to end ownership demands infrastructure that is not only scalable but also resilient and easy to manage. By leveraging OpenShift combined with HCI, you get a platform that automates deployment, scaling, lifecycle management, and which enforces governance and security policies out of the box. This reduces manual effort and accelerates innovation cycle. So hyperconvert infrastructure combines compute storage and networking into a single cluster. It allows simplified management, scalability, reliability, improved performance, data and enhanced data protection, cost savings, flexibility. It gives a software-defined infrastructure, improved user experience, and ultimately a cloud-like environment. So we will look at how this HCI can help us in the platform engineering area to provide resilient AI workloads. Now let's look at some considerations which are required to build an HCI solution. When designing an HCI solution, several factors come into play. It needs to be an appliance-centric designs to ensure simplicity and consistency. We need to have resiliency built into the architecture so there are no single points of failure. The overall software installation should be seamless and there should be unified administration between hardware and software to reduce complexity. Then we need to have a simplified storage configuration that would allow integrated support for streamlined operations. Then for day two operations, we need orchestrated updates, then hardware scaling capabilities so that you can grow your environment as and when it needs. Finally, there should be good comprehensive documentation and training that will empower your teams to operate effectively. Let's look at when we combine OpenShift with the HCI tolerant features, what is it we get? When these two powerful capabilities are combined, we can build multi-node clusters that eliminate single points of failure. You get redundant networking and storage paths. You get out-of-the-box load balancing and failover strategy. By combining these capabilities, you can see you are having a platform that is suited for running fault-tolerant AI workloads. Let's go through the key management capabilities that are needed for an integrated HCI system, primarily from an infrastructure point of view. We need the capability that allows managing of infrastructure at scale, where there is powerful automation and monitoring. For servers, capabilities including discovery of new hardware, network configurations, BIOS update, health monitoring, power management, alerting of critical events via SNM. And for GPUs, we need capabilities like workload scheduling, driver compatibility, validations, fault detection of the cards, integration with providers like NVIDIA, etc. And when you look at networking, we need redundant path, zero-time firmware upgrade for the switches. We need various customizable configuration that can connect this appliance to the customer data center, network segmentation, and many more. All these elements has to be combined in an automated way, which allows you to install, configure, and perform data operations, reducing manual intervention and improving the overall reliability. I'll now request my colleague to take you through some of the additional capabilities that an HCI system with OpenShift provides.
Hey folks, this is Rahul Nema. I'm a senior architect with IBM. I'm going to start with the storage. Our storage architecture is designed to be both scalable and modular, allowing it to grow for your AI workloads. It's container native, delivering high throughput and low latency that demanding AI and analytics application requires. We leverage high performance NVMe storage combined with erasure coding to ensure data durability, protection against failures, advanced caching techniques, and hybrid cloud connectivity further optimizes the performance and flexibility. Important, this storage solution is purpose built and optimized specifically for AI and analytics workload, ensuring you get the best of the possible efficiency and reliability with the storage platform. Now I will move to the next chart, which is out around the areas of enterprise grade storage. When it comes to data protection, we have robust backup policies and snapshot strategies in place to maintain data integrity. Our disaster recovery planning includes built-in protection with minimizing downtime and data loss. They are tightly integrated with OpenShift partner ecosystem, providing a comprehensive approach to resiliency so that they can recover quickly and confidently from any. OpenShift virtualization in general allows you to run virtual machines alongside containers on a single unified platform, eliminating the need for separate infrastructure. For GPU workloads, we support both direct pass-through and vGPU configurations, giving you flexibility depending on workload requirement. The setup provides strong isolation while maintaining flexibility across diverse use cases. With Hypershift, you can create lightweight multi-tenant clusters that scale easily and allow different teams or projects to operate independently. Bare metal deployments deliver the highest performance, ideal for real-time AI inferencing and training scenarios. Additionally, resources sharing capabilities make development and testing environments more efficient by maximizing hardware utilization. You can even assign dedicated clusters to different teams, improving management and security boundaries there. Now let's look at the day two operations which we should design for the platform. Operational excellence continues to well beyond initial deployment. Our platform includes monitoring and alerting tools that provide proactive visibility into system health. Auto scaling features dynamically adjust the resources based on workload demand, helping maintain optimal performance. Firmware upgrades and issue resolution are automated and proactive, reducing manual intervention and risk. These day two operations leverage Red Hat tools and deep integration with HCI component to streamline management and keep your environment running smoothly. We'll now look at the upgrade needs. Upgrades are often one of the most challenging aspects of managing infrastructure. The expectation today is simple: one click upgrade with zero downtimes and full awareness of running workloads. Traditional upgrade processes tend to be risky, time consuming, especially in complex data center environments. User worry about compatibility issues and security compliance when applying firmware and software updates. Our platform addresses these concerns by providing an end-to-end upgrade experience that reduces the risk, simplifies the process. Since bare metal OpenShift clusters are tightly coupled with underlying infrastructure components like servers, switches, PDUs, having seamless orchestrated upgrade is essential to maintain availability and performance. Now we'll take the example of Fusion HCI. What all? Obviously, whatever we have covered so far, Fusion HCI is built with these principles. IBM Fusion HCI brings together hardware and software into a tightly integrated solution optimized specifically for OpenShift and AI workloads. It includes built-in backup and restore capabilities, eliminating the need to source additional vendors and simplifying recovery from data loss or corruption. The system is pre-integrated, requiring no extensive assembly or manual configuration, which saves valuable time and resources. Setup procedures are streamlined with intuitive user interface, minimizing the expertise required and reducing deployment time from months down to hours. Fusion HCI also offers robust disaster recovery options, including metro level protection that ensures no data loss and regional protection that maximizes data loss during failures. High availability is achieved through redundant networking, highly available storage, and dedicated networks, and multi appliance upgrade and scale out capabilities allowing you to add applications easily as your cluster grows. Hardware architecture is purpose built for OpenShift and AI. The full GPU support, there is no need to design and maintain custom architecture or deployment models there. Additionally, IBM provides expert lab installation services and technical account managers who act as the consigliere, helping the adoption and ongoing management of the appliance. This single point of entry into IBM streams, support, and service, making it easier to manage your entire solution there. We'll now have a quick look at how an HCI platform can cater to real world use cases. The combination of Fusion HCI and OpenShift enables accelerated AI deployment model and training, helping organizations bring AI innovations to production faster. It supports generative AI applications that require high compute power and low latency. For organizations concerned about data sovereignty, on premise AI deployment ensure compliance while maintaining performance. High performance data analytics benefit from the scalable and resilient infrastructure, enabling real time insights at scale. Edge AI deployments become feasible with this flexible platform, supporting distributed environments closer to the data source. AI models lifecycle management is streamlined, providing tools to develop, deploy, monitor, and update models efficiently. Scalable AI infrastructure allows teams to grow their AI capabilities without disruption, while data cataloging and metadata management improve governance and discoverability of datasets. Hybrid cloud AI workloads can be managed seamlessly, balancing on premise and cloud resource for cost effective solutions. Overall, Fusion HCI combined with OpenShift deliver cost-effective AI platform that empowers organization to innovate faster and operate more efficiently. I will now request Shajeer to conclude on the key takeaways from the talk. Thank you.
Thank you, Rahul, for introducing IBM Fusion HCI, a solution that simplifies deploying and managing AI workloads with its built-in backup and restore, high availability capabilities, and seamless OpenShift and GPU integrations. With its appliance-based approach, IBM Fusion HCI cuts the deployment time from months to hours, and also with the expert support it provides with a single point of contact, it makes lives of everyone easier. This allows our platform engineering teams to focus on innovation instead of fighting with infrastructure challenges. The key takeaways I want to leave the audience with are IBM Fusion HCI delivers a resilient, scalable foundation that makes AI workload management easier and reliable. It empowers platform engineering team with end-to-end control, and enabling secure self-service environments. This reduces the operational overhead through automation like orchestrated upgrades and proactive monitoring ensures high availability. Together, IBM Fusion HCI and OpenShift helps us to create a future-ready platform that accelerates AI development, helping organizations stay competitive. Thank you very much.